Okay, so this was an interesting and actually pretty challenging review. Um, I may have spent a little too much time on the early. I wanted to go back and kind of trace the evolution of some of the ideas, and hopefully I didn't oversample on the early stuff. I didn't cover it too much in this. But oh, what? Okay, interesting. All right, so some of the main themes um, that I was kind of interested in touching on were having to do with uh, where behavior models sort of are and who they operate on. Like, and especially in the earlier days, we talked a lot about them sort of being side by side in the same column as sort of every tier. And at some point, we sort of pivoted to thinking about them more in the parent column. I think it's kind of interesting, and um, I'm kind of curious about the biology of that and what implications that might have for, the idea of columns having sort of a slightly different character and different and lower versus higher sensory areas.
Do you want to comment as we go, or do you want
Yeah, yeah, please.
I don't think I'm not sure you ended up where I thought every column can have behavioral models. It's just that the behavioral model, we ended up with the behavioral model didn't act on objects in its same module.
Hmm.
It's like it acted on child objects. So in some sense, it's like, yeah, that was the difference. In the beginning, we said, oh, in this one learning module, I can have a behavioral model and a morphology model.
Hmm.
And then and they can interact, which seemed natural. And but then we ended up thinking, no, the behavioral model acts more on the child objects. So behavior is just describing how child objects move relative to the parent. But it doesn't mean that there are different learning modules. They all have behavioral models and
Right. So I guess the question is, what are behavior models doing in the lowest level, like a
right,
one or
You
right.
could still use at the lowest level, you could still have a behavior model that can recognize behaviors, but then like you wouldn't be able to apply the behavior to a child object because there's no lower level. But it should still be possible to learn about changing things in the world and to recognize them again later on.
Mhm.
It is a little bit weird to think like, well, what is it going to do with that knowledge? It's sort of like I think I said this once before. The learning modules at the bottom of the hierarchy are kind of like the exception because they're like an endpoint. There's nothing below them, so there's a bunch of things that are a little bit different there. Um, so I guess I haven't been too worried about it, but it's a good point. I mean, and what do you think, Vivian? Is there anything could that other than recognizing behavior, would it do anything?
Um, yeah, I think recognizing it is already very useful because it can then vote with other columns as well that might be at a higher level. But
Oh,
yeah,
okay. So,
unless we want to add another mechanism, maybe similar to
oh,
what I was proposing with the balloon last
yeah,
time, where it is possible to apply a behavior within a column.
right.
Yeah, unless we would
And,
add
and, and
like
there's
that.
another idea too, by the way. We haven't really talked about how columns, or we should just say learning modules, um, generate behaviors from these models. And it could be that even a primary sensory column and a learning module could be generating behaviors based on its um, behavior model, right? It's
Right.
and we just don't have a theory of that yet. So that's a possibility.
And then the third purpose could be to assign behaviors to locations on a parent object, like basically knowing that at some location on the stapler there is the hinge behavior. So like basically that the behavior ID becomes a feature on the parent object model.
Right. So I guess in summary, Scott, there's a bunch of questions about this, but they're not fundamentally at odds with the overall theory yet. Just as questions we haven't really kind of resolved. Would that be a good summary?
Right. Okay. Um, and then some of these bullet points are just kind of interesting things that kind of popped up along the way, which I'll sort of maybe get into in a little bit more detail. I said pseudo parent objects. That's Jeff's example of the logo, the magical logo that can kind of just move around, whether or not you put it on a fridge or on a mug or whatever. Just kind of interesting thing to think about. And then, there was some discussion about model sharing and things like that. I have one example maybe talk about. And
I
then,
thought the pseudo parent thing actually, in my mind, was kind of resolved. It sort of, I didn't see any open issues with that. And maybe you do. I don't know.
no, a lot of these things are like just things that are in my mind that I could use some clarification on.
All
So,
right.
I think one interesting thing that came out of the pseudo-parent idea is that we can use the mechanism for modeling object behaviors to model like general movements of objects in the world, like physics and like how a ball moves through the room or something like that.
right. I guess
Or
my
even,
question with that was sort of was is it an actual 3-layer model that we're talking about concretely? Like, is it not a pseudo parent or is it a real parent? Does it actually take 2 columns to have a movie
mm,
logo and then a third column that also has the cup? And
well, you don't, in general, the way I look at this is you could do everything with two. I mean, that's what compositional objects, right? You could have a compositional structure that goes down many layers, but you can really only attend to two at the same time.
Mhm.
And so maybe the same thing applies here. It's like if I'm looking at an object like the cup with the magic logo that spins around, I found it easier to remember that with like the little square around it, just like almost like you can visualize a little square around the logo so you can see what the parent object to that spinning logo is. And then you'd say, oh, there's that square. Oh no, the square has this moving behavior. And so maybe the same thing is happening even if the square is not there. That's a good question though. It just occurred to me like the human body is sort of like that magic logo. I mean, we have all these parts, but every part moves. Every part can move. And so it's not like we're not very rigid, right? We're not really rigid things. So it may be even, something like the human body fits into the same category, that there's a parent object called the body, but all the components of it can move in different ways. And so there's nothing static about it. Anyway, just a thought
Yeah.
sort of popped in my head.
Um, and so sort of the next major bullet point here is precisely how the behavior model is used to sort of update object models or make predictions on object models, which we've discussed a lot lately. As just, I guess, a reminder to myself. Object and behavior models, they can be like co-aligned if we're learning the objects and the behavior at the same time, but we want them to be sufficiently sort of decoupled such that if that behavior is observed on a new object, it may occur at a different orientation and so on and so forth. So I don't know, I find something interesting about this connection during learning versus inference and sort of how that's going to work exactly, I guess, but that's just sort of a regular comment. Um, and I guess this last point here, treating application of behavior models like sensor movements, I'm just sort of underlining it because it didn't really sink in all that well up until doing this review for some reason. It's pretty fundamental, but it's just kind of like clicked. So I guess I'm just noting that. And here, this is just stuff we don't need to look at. There's some slides here we don't need to look at, but I put them here just in case nobody else did. Does anybody want to look at this? Or, yes, this is going to be the style of this presentation. It's just here's some stuff, and we don't have to look at it if you don't want, but um, we've
It's
gone.
beautiful.
Oh,
But
I didn't. First of all, I didn't make any slides. I took everything from everybody else. So
I think Vivian made this one, didn't she?
yeah,
I guess we can just.
we can come back
It
to
makes
this
sense
for
if just talk through this figure once, just to recap everything and make sure we're all on the same page with it?
Sure. So we've got two columns that are hierarchically arranged. Essentially, we've got sensors, sensor that sends in static features into layer 4, and changing features like an edge moving across a patch of retina or something like that moves into L3, layer 3. We have coexisting reference frames for the object model. I guess sometimes we call it a morphology model. I'll just call it an object model, and a behavior model. And they both perform, they're independent. They're not necessarily co-aligned. And they both have their own set of rotations that they essentially ask the thalamus to apply. We also have a timing signal coming in from the matrix cells, and that comes into layer 1, which we need for the behavior model. And essentially on the next layer up, in addition to relays through like higher order thalamic nuclei, we have direct connections that basically map feature changes into the object model. Like as far as I understand it, a changing feature can be a feature into the object model, and at least that's how we discussed it, into a higher order model and so forth. But this is sort of an earlier.
I'm confused about this. Where's the projection from region 2 to region 1? Really, where I just need a refresher on this. The behavioral model, how does it communicate to column 1?
Oh, this figure was made before we came up with that idea of applying
Okay.
it.
Oh, okay. I was gonna say.
And also, I wouldn't know actually which anatomical connections we would propose for that. So right now, I actually wouldn't know how to draw that arrow in
Well,
there.
but it needs to be there needs to be a connection. So
Yeah, basically, we would want a connection between like the movement stored in layer 3 of region 2 down to the reference frame of the morphology model in region 1.
right.
But I'm not sure, like right
That's
now,
the movement.
right now,
The big idea was the movement command has to be sent back down, and that's not
yeah.
shown. That's not shown in this figure.
Yeah, so I made that figure, I think, like a month ago. So then we hadn't had that idea yet.
So we're looking at the less optimal figure here.
Yeah, this is old. I feel like going through these videos the last couple of months feels like we're definitely gonna need a what was it? The presentation that Vivian gave was like Monty going around the map and just discovering all the new things. Like there were a lot
The
of twists and
Legend of
turns.
Monty.
Yeah, the legend. They're gonna need a Legend of Object Behavior version at some point. So just to sort of recap, uh, we're sort of taking the compositional object framework and sort of repurposing it with the inclusion of behavior models. This is a relatively newer one. This is sort of the review of the compositional idea, where locations on the logo, or sorry, locations on the cup are essentially associated with locations on the logo and so forth. And this also is older. So this is where we have a behavior, just essentially behavior model is somehow communicating with the.
All right. So this is old. This is
old.
we've abandoned this. Right?
Yeah, we're past this.
You're confusing us, Scott. You're bringing
All
back
right.
things we
Yeah,
want to
yeah.
forget
So
these things. These are like our exes. We don't
I
want
know, I
to
know.
think about them.
That's an analogy.
Well, it was hard for me to, just review
Wait,
the
hang on. What was abandoned about the previous one?
Well, that the behavioral model is in the lower column, informing the stapler's morphology model in the upper column.
Oh, but that's not what I was showing there. It was more about assigning the behavior to an object on a location by location basis. So basically, different
I'm
behaviors
sorry.
can exist on different locations on an object and at different orientations and scales. So basically, that's the same thing as we can have different
Yeah,
child objects on different
what's the scenario where we would have a behavioral model in the child object communicating with the
But
parent object?
basically, if for example, the parent object is modeling the human body, and then the body has a bunch of different behaviors at different locations, and so you would assign like the hinge behavior or the ball and socket behavior to the place where you have joints, and you'd assign a different behavior to the eyes and the mouth and the head. So like, or if you
Yeah.
have an object
All right.
where
So
like
this is all
there
right.
where
Okay. So this is the behavioral model in the right diagram here is not informing anything about behavior. It's just
no
saying,
no no
right. It's just saying there's a behavior model at this location.
Yeah, exactly. So basically
Right,
then
right,
if we see the stapler, we can
right,
infer
right.
that it should have that behavior. We can
Again,
infer, or we
okay,
can
so I saw it as, oh, this is we're acting on this behavior here. It's not.
no,
Which
this is not for predicting the morphology or anything like that.
right,
It's
right, right.
just about storing where on an
Okay,
object behavior exists and at what
right.
orientation.
I think the figures are maybe a little bit confusing in that regard because um, in some sense would be better maybe to combine these figures eventually. You know, we have essentially you have an object like the stapler and it has fixed morphology and changing morphology, and well, it has behaviors and it has features, and they're both part of the composition of the stapler, is what you're arguing. So
Yeah,
they both they should be shown at the same time, some sort of simpler picture maybe.
yeah. So I guess here I was just trying to make that one point in the figure, but like both
Yeah,
of these columns would have behavior and morphology models. And this is what I mentioned earlier as like the third reason why we might want to have a behavior model at the lowest column, because
right,
then that way we can assign behavior to different locations on an object. Like with the traffic light, the change of the color is at a specific location on the traffic
right,
light.
right. Yeah.
So
Well, maybe in terms of a a summary presentation, Scott, what we're looking at snippets that are on their own make sense to talk about, but they're not sort of the big picture, which is what's tripping me up a bit, right? So this, as Vivian, you said, this is a particular point, but it's not the overall picture, which is, I keep thinking, oh, we're going to get an overall picture of what's going on, but these are not it. These are components of the overall picture. Would that be a correct way of saying it?
Yeah, I didn't really attempt to make a comprehensive review of where things are at this point.
Yeah.
I really just tried to kind of pick a couple things that I thought were interesting and wanted to know more about.
Oh, okay.
So
but I think this slide summarizes a good point, which is basically, well, the first idea we had was that we use for modeling object behaviors, we use pretty much the same mechanism that we use for modeling object morphology. And in this slide is, again, the same point. We already have a mechanism for learning compositional objects. We assign child objects to a parent object on a location by location basis using hierarchy. And then we, again, can use the exact same mechanism to
Yeah.
assign
Are
behaviors.
we confident that this right side is actually happening? Is it necessary? Um, does
I mean,
I'm
I
not
think
sure.
if there's like change, so observations from the sensors going directly to the higher level column, then that behavior, like the individual arrows, can be learned on a location by location basis on the higher level instead of like on the lower level, and then assigning that to a location on the higher level. But I don't see why not it could also be in the lower level. Uh, yeah.
I'm just not sure if it's necessary in that particular diagram.
Yeah, I mean, I think like Hojae said, if we have direct sensory input, you can probably do a lot without that. But one, in higher regions, you might not have direct sensory input. And two,
Mm.
I think we already have access to these mechanisms. So I feel like this is just naturally happening. If we have object behavior ID that is recognized in the lower level column, that will just become a feature in the higher level column. So it's not like we're adding any mechanism, we're just using the mechanism we already have to deal with a new kind of feature that is being detected at the lower level.
But the behavior model in the lower column assumes that that requires something's changing relative to a parent. And it's not clear that that's actually happening down there.
There would be more just like local flow that's detected in the sensor, like movement relative to like
Yeah, but
behaviors
to have a
reference.
behavioral model requires that I have an object and I'm representing the changes to that object. So it's not just movement. Like if we had the logo on the left and the logo was rotating, as we said earlier, that's not really that unless it's the magic rotating logo, which introduces another reference frame. But if it's just rotating on the cup, that's not really a behavior of the logo. There'd be no spinning model of behavior, model of spinning on the lower level column. That would just be, from the lower column point of view, it's just, there's a logo and its orientation is changing. Not a behavior. The behavior model only exists on the right.
Yeah, with orientation, you can, I guess, just change the orientation, but you would still learn the timing of it, right? Like,
no, I don't think so. I don't think you learned that on the left side. The left side is just saying, hey, I'm seeing a logo and it's moving. Either it's moving relative to the sensor or it's moving because the right column is telling me to, it's acting like it's moving the sensor. But I don't see, I mean, I guess this is kind of the high level review we should be discussing here is like, to me, a behavior always is an object whose features are changing relative to the base, to the background reference frame. And in this case, I don't see that there would be a hinge mechanism on the left because you'd have to be recognizing the stapler to realize there's a hinge movement. And the stapler is only on the right. The stapler, again, is a complicated one because the parent and child are not really known up front. That's why I prefer the logo on the cup changing because it's easier to understand. But I'm still not convinced that the behavioral object would exist on the left side here in this particular case.
what about if we were in like a second and third level in the hierarchy? Like in the second level, you definitely have a behavior model. Wouldn't
Right.
you be able to assign that ID of the behavior to a location in the third level in the hierarchy?
So imagine we have the stapler has a behavior model, which is not shown here. And that behavior model would be in the right column. It's like, and it represents how it was learned by observing a stapler. And then the question is if the stapler is part of some larger object, like the desk, or I don't know, would that hinge behavior? I don't think so. I'm not. You might be right, Vivian. I don't think so. I don't see why there's a need for that. It feels to me it's just like, hey, there's a stapler, and there's a child object that has some behaviors. It could be the stapler, which we learned it with. It could be something else. But I don't know. I guess you'd have to, I'd want to see an evidence why you have to work it through, why it's required. I don't see it. I just keep coming back. The way I think about it is a behavioral model is always, and I started off earlier in presentations, previous ones. The behavior model is an object where one or more features of the object are changing over time. And so I'm always asking that question. So if I see this behavior model in the left column, I say, well, what is the parent object where that behavior is occurring? You know, I didn't learn hinge unless I saw there had to be something on the left that was learned. I don't know. What is the parent object there that behavior is related to?
Yeah.
It's not the top of the stapler. The top of the stapler the top of the stapler itself is not exhibiting a behavior. It's just moving through space. But as the top of the space, as a morphology object, is not changing.
Yeah, so I guess not to derail this review too much, I just wrote 2 open questions down for the brainstorming. So
Okay.
one, do we have behavior models at the lowest level? And second, do we need to assign behavior IDs to locations on a morphology model?
Right.
Or is that unnecessary? Does that kind of capture it?
Yeah, I guess those are good questions.
I guess when I think about the stapler, if we assign behavior IDs to different parts of the stapler and say that it's hingeness, who do I assign that to? Because I can open a stapler like this, but I can also move the bottom half. Which
Well, it depends on how you learned it. And some of the mug examples I presented previously, I touched on this problem. Like, remember where the logo could go up and down, there's no clear home position for it.
Mhm.
And so if you learn the stapler where the stapler's on the desk and the top moves, then I think you would learn a model that the bottom is the fixed part and the top is the moving part. If however, all staplers had, generally the behavior was you pull something down from the bottom, you might learn, like a little trap door or something, you might learn that the top part is the fixed part.
Okay.
It doesn't really matter because I think if I took a traditional stapler and I learned it, the top is the child object that's moving, and now in the future I hold it and I pull the bottom away, that's like I'm changing the orientation of the entire stapler. That's how it would feel, right? It would feel like, oh, I'm rotating this stapler. But if I just pull the top up, I don't feel like I'm rotating the stapler. The stapler isn't in a fixed position. It's just the top's moving. In the other case, I would say that the whole stapler is rotating. It just turns out that the top is stationary as it rotates.
Mm.
In one case, it's just where is the reference frame anchored? It's got to be anchored to some part, something.
Hmm.
Does that
Okay.
make sense?
Yeah, it does.
I mean, you can just mentally go through these exercises and see how it would feel if you learned it one way or the other.
Yeah. Hmm. Okay. Um, let's see if we can. Does anybody have anything else they want to say in the slide? So I'm just going to move to this next, more recent version.
That's good.
So, okay. Yeah, this is sort of a update in the sense that here we're sort of leaving out, well, first of all, the sort of overall point, which is what these last couple slides are, is just sort of underlining the repurposing of the compositional object framework into a behavioral setting. And so this is from Jeff's slides, compositional model over here, composition plus behavior. And here, as opposed to the previous slides, we're really sort of leaving off behavior, which it sounds like is still a continuing topic for discussion here. Yeah, so I think we've pretty much covered this, but
But I think it's just worth pointing out the point of this was the thing that Vivian and I both came up with, which is that the way you make a prediction about a moving child component of a parent is that the behavioral model sends movement commands to the child object, and the child object doesn't really know if it's moving through the world or if its sensor is moving relative to it. It's
okay.
sort of the equivalent.
Yeah.
So that's how we make predictions about a child as it's moving.
Right.
That was the key insight, I think, over the last few weeks.
Okay, well then this next figure kind of hammers that home, I guess.
Right.
Just sort of as a reminder, we've got a compositional object here. This logo is moving up and down, but in this example, the sensor is fixed. So the sensor is picking up on movement, which then passes into the behavioral model, into the next like higher level LM. Using a sequence of sensed movements, we can infer where the behavior, like where we are in the behavior, essentially. And we can take the inverse of the movement stored in the behavior model here. Follow this line. Can't see it. And apply the inverse in the same way, as you said, that we would apply movement commands to the sensor to sort of navigate through the object model space. It's a really nice idea and nice animation. So that's just a recapitulation, and like I said, like I understood it, but it like clicked a lot better as I was doing this review. This it's like pretty parsimonious concept of repurposing the motor commands to perform this task. There was an issue or like a two-part set of issues here. I'm sort of skipping over the first one and just moving directly into deformations. So for this one, like what's special about this balloon behavior is that it's non-rigid essentially. And if at some point the inflation stops, then, and we've only kept our sensor in one spot, once you sort of freeze it, it's very hard to make predictions about the rest of where the balloon locations are, because every location has changed over the entire surface of the balloon. So a few solutions were proposed. First, we just handle it as if there were a million child objects, basically. Um, uh, and then there was like this alternate solution that Vivian proposed, which is essentially a deformation of the object model space. I was kind of thinking about this and thinking like, we'd still have to store a lot of sort of point by point data, almost like as if we had a whole ton of child objects. But sort of thinking about it a little more, I guess what that gets you is generalizability. Like even though you're storing a lot of point by point information about the deformation, you do have the ability to like repurpose it for other non-balloon objects.
Yeah, so the key reason why I went forward with this idea is because like normally I would say this is unrealistic to be able to store so many point by point associations and all like how every location distorts, how this whole space distorts. But if it is possible to learn this on a common space for all objects,
Right.
and then apply it to any object, you basically only once have to learn all of that, and then, yeah, like you just said, be able to generalize it to any object space.
So that would be the same if you're just trying to remember all the individual components, right? There's another way that
It wouldn't be specific to any features or any components. It would just be the locations at which you expect features change. But it's not related to any specific features. It's not related to the balloon at all. It's just that basically the location space distorts.
Do you want to, how much do you want to keep this as a review session? How much do you want to make it a brainstorming session, David?
I think it would be worth to keep it mostly review for now and then collect the topics that we want to go into depth.
Just note that I had a thought about that help clarify this problem, but we can leave that for later.
Yeah, I'll write it down and then hopefully we'll have some time towards the end. But yeah, I don't want to dig too deep into just this idea right now.
The common space for all objects, it seems like naturally located in a higher tier LM, I suppose. Like if we're talking about a higher LM, which has multiple child objects, like what space is that exactly, if not a common one? I guess as I have a mug and next to a fork or something. Is that its own unique space?
You mean like kind of a temporary scene that we learned?
Yeah. Like,
Yeah.
would that be a space independent of mug next to spoon? Seems like we can't create a unique space for every uh, scene, some element of commonality to a composed scene, at least. I mean, scenes are a bit different maybe than nested objects, but
Yeah, I guess maybe the mechanism so far would say that if you recognize that this is a new scene, your grid cells would just anchor in a unique way and then you have a unique location space. But we also talked in the past about if this mechanism works like during object recognition when you have no idea about what object you're in yet, like what space would you be moving through, if you like you don't know which unique
I
location
think
space.
isn't there in the grid cell literature, I'm trying to make sure I'm not hallucinating about this. I believe that if an animal is put into an unfamiliar environment, and there's no way for the animal to recognize the environment. It's like, a white box, no features, no walls or anything like that. I think that the grid cells form a sort of common like a default configuration. Like there's like there might be a space for things where there's no obvious way to mark that. Like if I just imagine you had a spoon and a fork floating in space and there's nothing else to say, oh, this is in my living room or this is someplace. Or a rat sees a couple of features but doesn't have anything that are near each other, but it has no way of recognizing the environment, that there might be a common, like a default grid cell anchoring.
Yeah,
it sounds like
yeah, that's what I was kind of thinking of.
Yeah, it just reminded me of what you were saying. Just reminded me that.
Yeah.
And so that you go and say, okay, I don't really know where I am, but I can at least learn the relative positions of the fork and the spoon. And then all of a sudden I say, hey, wait a second. Oh no, this is in this particular space here. Then I'll create a new space and associate those. So you can have a bunch of children without a parent, and then it just goes to some default parent space. Anyway, said enough about that.
Okay, I'm just gonna move to sort of various other things I thought were kind of interesting that kind of got dropped along the way. And this being, I guess, the sort of stopping point for, well, okay, so I guess briefly mention that Nils also had a proposed sort of avenue for this kind of problem, which is a really coarse sort of rescaling. I'm kind of thinking of it as parameterization, like scaling reparameterization, but I just want to drop the note in that he had sort of brought up the idea that we may not actually make that precise of predictions about this kind of thing, and that
I don't remember him talking about that, but the way you phrased it, I agree with that. That was struck me as that this is very close to a scaling problem, and that we definitely could scale, just like we can change orientation, we can change scale as part of a movement. And then the more detail the more it deviates from just pure scaling. So the balloon isn't purely a scaling issue. But the more it deviates, then the more points you have to learn. And you could imagine something that's changing where the balloon's expanding, but the local features, there's hundreds of them around the balloon, they're all changing and spinning and doing various things. And that would take a lot of memory.
Yeah.
But
Yeah, I
in this
mean,
case,
I guess I would argue that there are lots of object deformations that aren't just changes in scale or rough
right,
changes in.
right. But one of the things I learned with the compositional research we did is that when the logo bent or something changed, or you had to store more information. If the logo did not change and didn't deform in any way, then a couple points are sufficient to learn everything. So the more unique the thing is, if you want to make predictions, you've got to store points. There's just no way around it. So I could have a really crazy, imagine this was a Rubik's Cube, right? And when the Rubik's Cube is rotating, someone's rotating, I look at them, they all look like a blur to me. I don't recognize those faces. It's just like, oh, this is a mixed up Rubik Cube. But a person who's really good at solving it recognizes those individual patterns as unique things and knows them all. Like it knows 1,000 faces of the Rubik's Cube. And so I just haven't done that. So those are like, to me, I can't make predictions about what's going to happen because they're random, but I could spend a lot of time learning it. Anyway, it's just an analogy.
I think I'm going to have to accelerate this because I've definitely exceeded my 15-minute
I'm sorry.
expectation.
As usual, it's mostly my fault.
So it's weird that I didn't tell it to do a click-through sequence on the text, but whatever, that's fine. I figured out the behavior. Okay, so this is another thing I thought was kind of interesting. Nils brought up this idea of sort of islands of agreement for neighboring LMs. So to be able to tell the difference between a stapler that's opening and closing and a stapler that itself is just rotating like that. And we've talked a lot about whether or not a single LM can do this, whether or not even if it can do it, it would just take forever to learn it. So this is kind of talking about the process of pooling information from LMs. I found this to be kind of a nice idea. And it was basically that LMs down here, let's say the top is rotating. LMs up here would be recognized stapler at given rotation. And LMs down here would be saying also stapler, same object ID, but different orientation. And maybe this is just more related to like the learning process. Essentially, when you have two sort of islands of agreement during the learning process but the islands are distinct from each other, then we sort of learn about the compositionality or about the object. So anyway, that was sort of brought up.
I thought we kind of agreed on, maybe not, but I thought we agreed on the idea that when something's moving, like the top, there's an automatic mechanism for isolating it and masking it. That's your second bullet point there.
Yeah, that was related.
That seems to somewhat alternate to what you just said. So maybe islands of agreement, intentional masking are two proposals. Is that it?
It sounded like they were related. I'd like to dig into it and get like maybe when Nels is back, we can talk about this more about the relationship between the two because you guys weren't disagreeing, at least in the video that I watched, but it seemed like there was some handoff between the two.
I'm very confident in the intentional masking now, so it's just I'm trying to understand it, how it relate. Okay.
Well, this last point I already sort of mentioned, and we talked through, which is having to do with sort of rescaling, and that's an alternative to maybe not alternative to Vivian's like graph distortion idea, but more like places constraints on how detailed that distortion model has to be, or not constraints necessarily, but has implications for efficiency.
I think this last point, parameterized rather than location by location, I don't think those are alternates. Essentially, I mean, I think what you mean by parameter, like what's the scale, what's the orientation, right?
Mm-hmm. Yeah.
As I said a moment ago, you could have one set of parameters that could, in theory, define the entire relationship between parent and child object. But when things get more complicated, then you have to do it on a location by location basis.
Right.
So that's what we learned about the compositional model. It's always done by a location basis, but you don't have to learn many points if parameterization works, right? So a rotated logo is easy just to say, oh, at one point it's at this angle, and I can path integrate and know what it's going to be at any other place. But if the logo bends in the middle, then I have to have multiple locations where I learn the parameterizations.
Right.
So it's not one or the other. That's what I'm reacting to here. It seems we do parameters. Everything's parameters. It's scale, location, orientation.
Right. Okay. So it's
But
more of a granularity.
but
Like
you
how
do it, the granularity, this has become very clear to me. The granularity is required if you want to learn more, if you want to know the details. Like I mentioned with the Rubik's Cube. If you don't really care, then you don't see it, you know.
Hmm.
But if you would really want to learn it, you got to spend time paying attention to it.
Okay.
Maybe
Uh,
another analogy to, like, if you're more familiar with Matthias, it's maybe a bit like the feature change sensor module. If the parameters aren't changing, then you don't have to lay down a lot of points in your model. But if the parameters like scale and orientation are changing, then you have to start laying down a lot more dense points, similar to like the feature change sensor module, where if it detects no change in the features, like you're moving on a flat surface, it doesn't send a lot of points to the learning module, but
Right.
if the features are changing rapidly, it sends a bunch of points to the learning module.
And the evidence from neuroscience is that when things aren't changing, the sensors don't send anything. So the entire thing is filled in, you know.
right. All right. So I'm gonna hop off because we've only got 40 minutes left for the remaining speakers. So I have been kind of thinking about this problem a little bit lately. I kind of thought about maybe just posting it in the research channel to think about what everybody thinks about. But this is sort of like the inverse problem of a sensor moving around to sense something. Well, let's say somebody traces a letter on your hand, and they're all different sensors basically, and yet it's like the opposite problem of a sensor moving around and collecting a bunch of data. It's all different sensors receiving input at different time, and somehow you're able to sort of temporally pull them into creating a letter. Just throwing it out there because I was thinking about
You
how this.
know, this is a really
I
good
don't think I can do
example.
that.
Sorry, don't you have written letters in someone's back?
Yeah, like that's what I was exactly going to say. Like if somebody writes something on my back, I don't think I can recognize it.
Even a letter?
I just tried K and I was like, I mean, like, okay, I
Well,
know it's a K, so I
all
guess.
right.
Anyways, go ahead,
You
Jack.
know, too much sharing here, but I've done this with my wife and she's done it with me, and you write on your back and you can do it. You can't do it extremely accurately, you know, but you can do basic letters. It's doable.
But I think on the hand, you can do it more accurately because you have,
Probably because it's sense. Well, I think what this gets to that issue I brought up recently over and over again when we're talking about the issue of, you know, shared learning. And I propose that the hierarchy is how this is done.
Mhm.
I don't think you could do this at a single region with multiple columns. I think this would require moving these data points into a higher level representation in the cortex, which is also visual in some sense, right? It's visual or touch. We haven't resolved this issue, but I think that's what required this. It's a good example, Scott, because I don't think there's any way a single region could do this.
I think that's kind of, at least through introspection, what I feel like you do when someone draws on your back, you actually try to visualize it,
Right,
like
right,
how it would look. So
right,
it's not like you're just paying attention to touch, you're actually trying to mentally visualize it.
right. That's my point. And that's what happens when you learn an object through touch, right? If you reach your finger into a box and you're tracing the cup or tracing an object, you simultaneously are visualizing the 3D structure, and you can see what it would look like as you're doing that. So that just tells you that you're feeding this up into a region that is already integrated multiple columns in, and you're forming a representation that's not specific to the palm of the hand or the back or anything like that. You're forming a representation that's independent, more generic. We haven't dealt with that. But it's a good example. Help us think.
Yeah. Couple more thoughts on that, but I'm just gonna table it. So it's not
It is the exact opposite or flip of like reaching a finger into a black box to learn the shape of an
It
object like
is,
that.
yeah. And it's not even quite the same as like tracing something out with a finger and relating it to vision because, you know, it's not one sensor, it's many sensors.
Right.
Like you never
Anyway,
activate it, yeah, but
right.
okay. I'm gonna um stop there.
That's a good problem. I like that problem. Our series have to explain how it works.
Yeah, it's
I think
really good.
it'll fall out nicely, I think. I think it's just a nice look. Another constraint on the hierarchy. This is good.
Ramy, do you want to go next? I think you
Sure.
also have some slides.
I did create some slides, which is a kind of a risky move because of the complexity of this subject.
I mean, I only have Excalibur if you want me to go next.
I'm sorry.
I only have Excalibur if you want me to go next.
So I didn't really address everything with my slides. So I realize now after Scott's presentation that there's a bunch of stuff that's missing here, and maybe the important stuff. So let's see. I'll try to go through them quickly and
Yeah, and Hojae, if we don't get to you today, we can just pick it up there at the beginning of the brainstorming week. But hopefully,
Yeah, I hope.
yeah, again, I'll try to go through this quickly because most of this stuff is we already know this stuff, or we already this is like a recap of not very new ideas, I guess. So we'll go through this quickly. We already know this, building a morphology model in some lower level column, the movements and the features, and it's building a morphology model, and we're pulling that into an object ID, and that's coming from first order the thalamic relay cells. And when we expand this to a behavior model,
the fancy behaviors on this.
I think we need a whole lesson on how to do these fancy animations.
it's easy in PowerPoint. So now we just have delta features. So that's the only difference. We have the same movements. They're changing a different reference frame, which is the location reference frame of the behavior model. And we just have delta features now. So any changes are going there. And we're just also pulling that behavior model into a behavior ID. I'm still, I think I'm at the same place as Scott and Vivian, thinking that there's a behavioral model everywhere, even in the lower level columns. So that's how I'm gonna keep presenting this.
By the way, I agree with that too. I was questioning the projection of the behavior model to the parent.
Okay. Yeah, I think I still have that in one of the slides. So I realize now that there's a discussion on it, but
I don't want anyone to think that I'm going away from all columns to do everything. I think that all columns do everything. So
okay. So now let's talk about higher level column or high level region column. So in this presentation, I'm just focusing on what is being fed into what in the feed forward. And I will talk briefly about the feedback, which is, I realize now is a big thing. But I'm not really drawing it here, but I'll talk about it. So what are the inputs to a higher level morphology model? Well, the first input we have is the larger receptive field features that are coming into the layer 4, which is these are just features coming from the higher order relay cells, thalamic relay cells. And that's also helping us build a morphology model in the parent column. The other input is we're getting the object ID. So everything that is static, basically, we can associate that in the parent column. So the object ID is also coming from the lower region column, and what that's helping us do is assign, like we can do here. We can say there's a TBP logo here, there's a TBP logo here. This is a cup, which I think it's okay to say that there's a model of the cup in the higher and the lower regions, and we're just assigning. We're just saying it's a model of the cup. This is still a cup, and it's being assigned at this location. So it's just saying this is an object ID of the cup here. So it's getting the object IDs. Another thing that it's getting is the relative orientation. So I've added a little tag here that says, so basically this is the global orientation of the object that we've learned, or the behavior. what is getting here as features is the relative orientation. So we can say the logo. So these, first of all, these orientations here are with respect to the sensor. So that's basically saying how oriented the logo is with respect to the sensor and how oriented the parent object is with respect to the sensor. We can calculate the relative orientation and then send it up to the features. And we can store it. We can store these at locations as well. The useful thing about this is that we can now, if we know the orientation of the parent object and we know the relative orientation that we stored at these locations, at any location we can calculate what the child orientation will be because we already have stored the difference and we know what the parent is. So I know this is recap, but I'm just going through it again. Now, this is, I guess, the point of confusion a little bit. I'm just assuming that if we already have a behavior model in the lower level, we can access it, or we can also associate different behaviors at different locations in the higher region. So in addition to pulling the object IDs and the relative orientations and all of that, we can also get the behavior ID and say, at any of these points, we have this behavior. If you think of a stapler, you can say everywhere there's a hinge except for that little deflection plate or the anvil, as they also known as an anvil. There's a slider behavior, or there's some other behavior. So on the parent object, we can just assign different child behaviors at these locations. So now let's talk. So this was all just a morphology model, and it's getting all of the static features that we have, whether from the thalamus or from the lower level region. Now let's talk about the behavior model. The behavior model is only getting changes in those features. So I'm going to go over these features again and just
So now we've switched to behavior model in the parent now, right?
Now this is only the behavior model.
Uh-huh.
Just for simplicity, I've just removed the morphology model, which we already.
I guess the top text box should say behavior ID, right? In the second column.
Oh, right.
Yeah.
Sorry. This is a mistake. Yeah, a typo. Yes, my attention was just on this. But yes, the behavior model is pulled into a behavior ID over here. So these are the delta features. So all of the 4 things that were input before to the morphology model, now we're going to inspect what the changes and features in here would represent for those. So we still get the features coming from the thalamus, but these are going to be changes in large receptive fields features. So still getting the direct sensory input. I don't know how far this will go, especially to higher level
So
regions.
this behavior is the one logo turns to the other. Is that this behavior?
Right. This example over here, yes.
Yeah.
But any change, so this is direct sensory input, so any change, it will basically capture it as just change in sensory features, direct sensory input. Here we will not store anything, and that's important. So nothing is getting stored into the behavior model because we're not seeing anything here, similar to the lower level behavior model. The other thing is we're getting also a change in the object ID. So as this logo changes, we can store something like TBP to cup or TBP to Numenta logo. There's no change here, so we're not storing anything. My thinking is that anything that we store as a change is really useful in the feedback connection, because we can query at any at any timestamp in the behavior model. We can say, okay, we're in the middle of the behavior. I can see that the change is basically going from TBP to cup. Then I can feed that back into the lower level and bias what object ID I should be seeing now. I should it will go to the layer 1 and through the apical dendrites connect to object ID in layer 3 and say, okay, you should be seeing now a cup or an Numenta logo or something like that. At least it would bias it, and then it would consolidate with whatever input.
Yeah, what I tried to make in the last few weeks is that this type of behavior has a qualitative difference than the behaviors of things moving. And there's nothing moving here, right? We're just changing an ID. And so that's very different than if the logo moved or if the stapler top moved. This is really, we're just learning ID swapping. And I just want to point out it's quite different. So we have to learn it. I think the mechanism we learn it, but it's a misleading one to think about initially, because there really isn't any kind of movement information to be passed between the, and it's very specific. Like I can't turn this behavior learning that one logo turns into another into a different object with different logos, because I just, there's no way I could predict that, you know, a Ford logo turns into a, you know, Coca-Cola logo or something, you know what I'm saying? There's no analogies there.
It's kind of like the qualitative difference we talked about before between, like if we just look at object models, there's kind of a difference between the oriented features like oriented edges or the orientation of the child object to the parent versus specific features like the object ID of the child object, where we talked about how maybe the
Right.
orientation, the mini columns, and then the ID of the child object is specific activations in those mini columns.
Right, it's very different. The way we represent the
Yeah.
color is different than the way we represent the orientation of the edge.
Exactly, yeah.
Right, and so you're right, that's a good analogy. That's what's going on here. So just, we have to be very careful. This is, to me, the less interesting example, the one that's really not it's not as useful in terms of creativity of a human or an animal or Monty.
And I think it's a good, the easier example to start with to explain the behavior models, because it's like the first step in the mechanism, storing changes.
Yeah, although again, these changes are changes in ID and not changes in behavior, shape or movement, or, you know.
Right.
Most of what we want to have an intelligent agent manipulate the world, it's not going to fall under this one. But the vast majority will be under things moving and actions, and things like that.
But this is probably still going on to be able to model these
Right,
kind of.
we have to explain this one, but if we focused on this one, you're going to miss the key parts. You would never have thought about sending movement vectors down to the child. There's no movements.
Yeah, I think Ramy's getting there.
Okay.
It's a really nice presentation, by the way.
It is. I just want to, I know that I spent a lot of time worrying to think about this, and it took me a while to really crystallize there are differences here, and this is a key difference between, so we don't want to focus too much on this, but we can keep going. But I don't want anyone to think, oh, this is behavior. This is a corner case of behavior, and it's qualitatively different than most of them.
Right. So the way I think about it is that there is no movement that we can pass into the location reference frame here, but there is a change that we can pass into the object ID layer.
Right.
By what's happening. So
right.
I actually I wish I had more slides to cover the movement part, but I'm just going to try and talk about them when we get there. The other thing is the changes in the relative orientation. So I'm not sure if this is an old idea now, or if this is still valid. But basically, in addition now, so we were getting in the morphology model, we were getting the relative orientation between the child and the parent, and we were storing that. Here we're getting the change in the relative orientation. So let's say we were at like 50 degrees, now we're going 60 degrees, 70 degrees, whatever. It's like it's a change in that relative orientation.
It's careful. This is not just a change in orientation. Remember, I gave an example where you could rotate it around one end of the logo.
Right.
And so this is not like, oh, all I need to know is the orientation is changing. I have to learn this on a location basis. This is a change in location and orientation. It's tempting to think, oh, I'm just changing the orientation of the logo. No, you're changing its position and its orientation. And that the example I just gave is proof of that. So you can't isolate this as just orientation features. It's orientation and location at each location.
So what we're storing in the morphology model, we're storing the relative orientation only, or we're also storing the relative orientation and the
Well, on the morphology model, you store the location at an orientation at a location.
So
or
basically,
change.
the features that are stored will be the relative orientation of the child to the parent, but that relative orientation is stored at a location in the reference frame of the parent. So if you have this logo rotating, you both have a change in orientation, but also you change at what locations that logo will exist.
Yeah, this is. Oh,
But this is all right. It's just an additional thing that will need to be
You
learned.
can't just change orientation. That's not possible.
okay.
And the proof is if I change the orientation based on a different point on the logo, I'd have different predictions. And so there isn't just a way of saying change the orientation of the logo. It's actually changing its location and orientation at multiple points.
Let's see.
But yeah, that doesn't invalidate the slide that you're showing there. Everything you show here is like still.
Right.
still
Right. It doesn't invalidate, but I know there's a tendency to think like we're just changing the orientation, and I'm trying to banish that thinking.
Right. Yes. I just have to think more through this and get back with questions, I guess.
That was part of the problem learning compositional objects. Is that we thought, oh, you could just learn the orientation of the, you can't just learn. There is no home point, there's no anchoring point. Anyway, I've said it enough, right?
Okay. So the idea here for the feedback would be that if we're storing that change in relative orientation, can we also, so we're storing the change in relative orientation and we know what the current orientation is. So the behavior model will be able to instruct the morphology model to change to basically know where to expect the morphology of the child object to be as it changes. That's still valid.
Well, the parent is going to send a movement command to the child, and the movement command can be both. It can include changes in orientation, and it can include just displacement. Like non-changes in orientation. Just think about that. Both of those are valid movements. You could, there could be a rotation at some point, and it could be change of orientation. So when the movement commands gets parsed by the child into an updated orientation and location of the sensor.
Okay. So in this case, sorry, go ahead.
Yeah, so yeah, what you said is correct, that the parent column can send a change in orientation to the child, so the child expects the logo to be at a different orientation, but at the same time, it also updates the location on the logo it expects to be on, because if you look at the little sensor patches, they change.
Right.
Not just the logo doesn't change orientation, it also changes where the patch is on the logo. So it will also move you through the reference frame of the child object.
I see. Yeah. Okay. Got it. Yeah. This is the movement part. I think I'm missing here. But yes, I think I understand what you mean. So this would assume that all of these movements that we store, whether for scale or for the logo going up and down, we would be just sending the movement back to the reference frame, the location reference frame of the morphology model, and we would just be inverting that. And by inverting it, we're basically staying within the reference frame, or like there's nothing changing in the child reference frame because we've inverted the movement that's coming from the higher level, the parent object.
Yeah, I would say scale is a bit more similar to orientation. Like that's more like a general transform that's applied to everything that goes in, like to all of the movement vectors that go into the child column, versus like movement of the whole child object is then actual movement vectors being applied to that reference frame.
Mhm.
So like,
That's it. That's interesting because in the brain, I don't think it would be that way. That may be fine for Monty. If you think about the information coming from your retina, right? Going back to the example, you're watching someone play a video game.
Mhm.
And as you're watching that someone play a video game, you know if they're changing their orientation, if they're going forward, going backwards, turning left, turning right. There's one signal coming from the retina, and the cortex figures out how to update the location and orientation from that vector. So in that case, we wouldn't be if the brain, I wouldn't expect the brain to send back a signal saying change your orientation or move in some direction. If it would model what you're getting from the retina, it would just be a movement vector that the lower learning module has to interpret. It says, okay, what does this movement model mean? But we can do whatever we want in Mani, so I'm not saying Mani has to do it that way.
I mean, I still feel like it's a qualitative difference because the orientation applies to the entire reference frame of that child object. So you apply the same orientation to all of the movement vectors that come in from the sensor versus the
Right, but in this case, right, but we don't know that, right? If you were thinking about multiple fingers, the orientations of different fingers next to each other could be different.
yeah,
The
those are separate columns, so each of those have just one
Right.
orientation relative to the object.
All right, so it's only you could say is that the change of orientation at this point, because you go to a different point, you might have a different orientation. So you can say I'm applying it to the entire object, but it's really I'm applying it to this point, and I can interpolate that it's the same orientation everywhere, but it might change. The logo might have a curve in it or something.
But then that would have to be learned by hierarchy. You wouldn't be able to do that within one column.
Well, all this is learned in a hierarchy, right? Isn't this? We're
I
looking
thought
at
you were just talking about the child column, which is maybe at the lowest level, changing the orientation at which it thinks the object is relative to the body. So we can do that reference frame transform from.
But you can only say that's true at this point. Because if you move to another point, you might get different instructions and say, oh, I mean, yes, we could, without further information, we can changing the orientation of the entire object. But often there is additional information, and the orientation, as with the logo that bends, the orientation can vary at different points. So
But that's in the parent column that we have different orientations at different locations. That's basically what's stored in like the mini column.
Right. So I'm a child. I can say, all right, at this location, I have this orientation. I can then interpolate. I can, predict what's going to happen elsewhere. But if I go elsewhere, I might be told that the orientation has changed. So it's
Yeah,
not
that's
always.
more what's in the mini columns in layer 4. But what I thought we were talking about is like what layer 6 sends down to the thalamus to
I think.
transform the movement vector into the object's reference.
Okay. Well, maybe there's something we should discuss offline.
Yeah,
about
maybe
that.
it's a misunderstanding because I feel like
Yeah, because I also think so. I don't know if we handle
Oh,
the
I see what you're saying, Vivian. I get your point. All right. I'll just leave it at that.
yeah, I would be very confused if we disagreed on that because it's like a very
Okay. Right.
foundation.
Okay. I just want to make sure that everything is done point by point. And if you don't get any additional data, that you can interpolate.
Yeah.
But everything's done point by point. So you can't make an assumption about you can't make an assumption about an entire object, a child object. You point by point and
Yeah.
you interpolate unless you get some additional data. Okay.
So in the case of a logo that is stretching like this, excuse me, this will be solved with the mechanism of movement. We're restoring the movement of the like the movement vectors and the behavior of the parent object, or in the behavior model on the parent object, and we'd be using that to change the
No, I don't think so. This in your previous image, we're touching on the issue of scale. And if you go back in all of our previous talks, we've avoided talking about scale.
Okay.
This is saying the scale of an object is changing at certain locations. Again,
But
at certain locations, it doesn't have to be, we can look at it and say, oh, the scale of the entire object is changing in the y direction. But it could be just over 1,000 scales, it changes, or it could become, wobbly shaped. So it's basically, we're changing scale on a location basis, just like we can change orientation on a location by location basis.
yeah, I
That's
feel like
how-
this is this distortion problem that I'm trying to get at. Like, how would we deal with those kind of distortions? Because it is not just scale; it's scale in one specific direction.
Right, well, that's just like, but again, if you think about a point by point basis, you can do that.
But not in the lower column. If it then if the logo stops at the stretch part, and then you
Well,
move
then
your
you'd learn
sensor
it, then you'd
over.
learn that, right? You learn it. I don't know. I think if I did that, I wouldn't learn it as a new word. I would just learn that's a logo that's stretched. It's a new one. All right. Well, this is a good, this identifies an area that we haven't really addressed, which is the scale issue. I think this is a scale issue. And so scale and orientation can both change point by point if we want them to, or they can change in all at once. So this is a good example. I don't think we've dealt with scale enough.
Okay.
Unless someone disagrees, I don't think we've really talked about it enough.
So the other thing is the other change that may become a feature or a delta feature in the behavior model is a change in the behavior ID. We haven't really talked about this too much, I think. But I think this is how I couldn't think of an example, so I didn't put something here. But if a behavior ID, so a static behavior ID is fed into the morphology model, but if the behavior ID changes, I wonder if that gives us some sort of compositional behavior.
I can't imagine what that is.
I can't either.
Yeah, I think we talked about that before, that we can't think of a good example of a compositional behavior, so it might just not exist.
Right.
Yeah, but I think we may have the mechanism to, like, if we do it in a compositional way like this, or a
I
hierarchy.
can't even think of anything that would make sense in this regard.
Yeah, and that's because the behavior ID is usually over time. So you can't think of something changing at a specific
Well,
location.
no, the behavior ID is consistent over time, but you're saying, I think what you're saying is I have a staple at one moment, the hinge goes up, and another moment, the hinge goes sideways or something like that. I don't know.
Like changes from
Changes?
something else, but I don't see how that would happen. Yeah,
Right. And I'm still questioning this feed-forward projection as you're showing here.
right.
So,
Yeah, I'm just trying to cover all the things that were static and we're going to the morphology model now. What happens if we're getting changes of those into the behavior model? So yeah, so maybe that answers the we don't really have compositional behavior. We can't have those.
no, this is not sure. Can you reach that conclusion? I think what you're changing, if the behavior ID changes, and we said no, but that doesn't mean it isn't composition. I mean, it's not. Compositional behaviors could be just I don't know. I have to think about it.
Yeah, because every time I try to think of something, it ends up being like a causal relationship. Like I turn on the light switch and the light turns on or something. But I don't know if these are compositional behaviors or just some causal behaviors.
I think we're getting sloppy with the language here.
And yeah, just to confuse myself, I think I just started thinking of breaking off a logo into like different behaviors and just thinking
Why do you
through.
say those are different behaviors? That's one behavior.
Some of them are stretching, so they're moving.
It doesn't matter. It's one behavior. Because a behavior is defined as changes to the features of an object. And those changes can include everything, like orientation, scale, rotation, location, that doesn't matter. So to me, that this isn't multiple behaviors because these are all changing at the same time.
But wouldn't you say in this case we would decompose the logo into multiple child objects that are basically the words of the logo, and then each word has its own behavior because they move independently.
But they don't really move independently. They move into, they're moving relative to each other, but they're moving together at the same time. It's not like the one word's floating around, the other word's floating in a different direction.
Yeah, the timing
Um,
is synchronized, which would be easy to do with the timing
I-
signal, but
this-
it just
This to
seems
me
like
feels like this is one behavior. This doesn't feel like, oh, there's 4 behaviors going on here.
If we do this at a location basis, then yes, every little feature is just creating one big behavior. It's orchestrated with like all these changes of the features are changing together.
Right. Just
Uh,
like, you know, we could define a behavior of a stapler, then when you open the top, the deflection plate rotates. This is just a flavor of that. You've got 2 parts of the object that are changing, and they're changing independently. I mean, they're not independently, they're changing at the same time. They're tied together. So I don't think this is one behavior here. This would be one behavioral model. This is not 3 behavior model. I don't think like, oh, the word project's going to move up and down. Oh, and then separately the word thousands is going to move up and down and up. No, they're all changing together. We have to come up with, this is a single model. This feels very strongly. This has to be a single model.
I think I feel very tempted to break it off into separate objects because
It is separate objects, but not separate models. It's one behavioral model. Right? Just like
seems
the
like even as
deflection
you're
plate.
describing it, you're breaking it into different parts.
Just like the deflection
one
plate in the
learn
top of
it?
the deflection plate in the top of the stapler can be one behavioral model, even though they're separate childs. So all I'm doing here is I'm just turning, instead of having one child object, the stapler, I'm having 4 child, I'm taking something and breaking into 4 child objects. But each one it's all part of one behavioral. It seems so obvious to me. Because these things they all change together consistently, then it's one behavior. I don't view this as 4 behaviors. I mean, just conceptually, you look at it, you don't feel that way. You just feel like, oh, I know what's going to happen.
I feel like we could build a behavior that is composed of all of these little behaviors happening together.
Right. But I think it can be done with one behavioral model. I don't think you need multiple ones. I'll have to work through the details. But you identify this as a single thing, not as multiple things. You break it apart, just like I break apart the top of the stapler from the bottom of the stapler, or just like I break apart, you know, the top of the stapler from the deflection plate. This is an intentional mechanism. You have to attend to all 4 of these components to learn this behavior. But it's really no different than the stapler top and the deflection plate. I think
It makes it a lot more difficult to do the solution of applying movement vectors to the child object to make predictions. If we would just say we decompose this into 4 child objects and those move, then we can do that solution where we apply the movement vector and expect to be on different locations on the words. But if the words are all moving in different directions, we can't do that anymore. We can't just apply the movement vector to the whole.
So I think this is a good example. Another one, you've come up with several good examples, Ramy, where we say, okay, how does our behavioral model solve this problem?
Yeah, I wrote it down as an open question.
All I'm saying is that this is not 4 behaviors. This is clearly, in my mind, one behavior. If these components moved independently of each other, yeah, it'd be 4 different behaviors. Like if the word project could move sometimes and other words didn't, and they independently did their own thing, yeah, sure. But since they're all going together, we group these together as a single behavior. I don't think this is.
I agree that we would be learning a single behavior eventually, but I feel like it might be easier to assign to break them off and assign simpler primitive behaviors to these, and then build a higher level behavior.
All right. Well, we'll have to see. Let's leave that. I don't think it feels that way at all.
Maybe that ties into the compositional behavior.
Maybe.
This clearly is, I don't say, oh, look at the word project is moving. Oh, look down here, the word thousands is moving. No, they're all moving at once. I see it immediately. There's no question in my mind, this is one thing. After I've seen it repeat once or twice, yep, that's one thing.
Right.
All right, so we just have to make sure.
As a question to tackle during the
I think this is a good extension of our behavioral model to see how do we handle this.
Right.
And clearly we have to break out the components, just like we broke out the top of the stapler. So it just tells me that there's a separate, as part of a single behavioral model, the movement vectors, I have to send different movement vectors to different child objects. And so the behavior model has to manage that, has to do that.
Okay. Just my last slide. I think only just talk about only the first point. I confused myself a little bit making those slides. So this is a question of if we have a change of logo on a cup, just like the one we have, is this considered a behavior ID in region 1 that would be assigning to a morphology model in region 2? Or this is just a change in the object ID, like from TBP to Numenta in region 1, and we'd store it as in the behavior model of region 2. So it could, I feel like it could be stored either in the morphology model as a behavior of the lower region, or it could be stored in the behavior model of the region 2 as a change in the object ID of region 1.
Well, I vote strongly to number 2 there. That's my vote.
Change in object ID.
Right, and I think all these considerations of these behavioral models in region 1 are misleading.
I see.
That's my feeling. But you know, I'm just stating my opinion. Doesn't mean I'm right. I'll make my point in court in 2 weeks or whatever it is.
Yeah.
I think this is it. Sorry, Hojae. I think I
That's my fault.
Is it okay if I still present, or
Yeah,
do you guys just want to?
I like
Go
you to
ahead.
at least go get started.
Yeah, I mean, feel free to drop out if you need to. And
Yeah,
I'll
we're
just,
starting.
yeah, and I'll skip the review portion of mine, because everybody has reviewed it now. Okay, so can you see the Excalibur? I think this is also in our group, like Excalibur, what is it, like the brainstorming scenes or something like that, or the brainstorming, whatever. So yeah, everybody has done the review. You know, I think the presentation that Vivian gave, I think this was mid-April, so just like less than a month ago, or like something like that. There's like a huge like goes through the, you know, the like kind of our current setup and the assumptions. I thought this was really good. So like Will, if you could put like I don't know if Will's here anymore, but the like, you know, the video, if this is a video on YouTube, it's like put the video thing here. It's like please click here um to like see that, because it's really it's really good. And of course it's the research meeting that I missed, so no wonder why I missed a lot. No wonder why I was confused for like so many weeks.
Yeah, that's not a problem.
And yeah, and then the other behavior movie that I thought was really good was Jeff's one. Sorry, I don't have a really good screenshot, but the key that I think the most important takeaway from this was like the this section. Like I know there's like other important words here, but getting this movement out from behavior model was like a kind of a it's like, oh yeah, like that's a novel idea that helps us predict what the sensor will see, like what this, yeah, was through the movement.
By the way,
And then
Vivian had the same idea, but we used such different language that we didn't understand that was the same idea.
yeah. And then I think it's probably worth revisiting, you know, what we need to solve at the beginning of the brainstorming session and maybe updating it. I think from what I like understand so far, I think that the final open questions, at least for me, is talking more about the how we learn the behavior model and then generalizing the behavior model to novel objects. I know we talked about like associations, and so we did talk about this a little bit, but even going kind of back through the video, it's like I don't really quite it's not very tangible for me yet. And then last week, Jeff presented this kind of framework for slow learning and fast learning. Sorry, Jeff, I have no idea like what you're talking about still here. I know that you were going to try to apply to like object behaviors, and I look forward to that. But so far, like, yeah, but literally, this is what I feel like.
This was not about object behaviors. It's just
I
about
know
learning,
it's like a
learning in
yeah,
general.
learning in general. Yeah,
Oh, all right. Sorry, I didn't
yeah,
understand that. Okay.
yeah. No, it's. I mean, yeah, it is what it is. So I just wanted to present kind of how I'm personally, like in my brain, like what I'm thinking about when we think about behavioral models. So this is very, low tech kind of behavioral model rolled out in time. So we have to learn some kind of like change over time. So we're actually learning multiple things. It has been like always animated. So like for the stapler opening, for this particular location, like, imagine there's a stapler for this particular location, it's moving in this, direction. Next time point, in this particular location, a stapler, it's moving that, whatever. And same for t equals 3. And I think stapler hinge opening is actually a little bit complicated. Um, and I think the mug changing color is a little bit easier to understand. But basically, in the behavior model that we have, like the little square animations that we always had, basically I just threw them out, and then I put like a label for X and Y to indicate that this is a change in like a physical space, like the a particular location in a stapler is moving, in this velocity, whatever, at a certain time. Um, in a like mug changing color. So imagine there's just a simple, I don't know, like imagine this is like all green and it's just going like rainbow, like green to blue to red to whatever. Um, in this case, at this particular location of the mug, so maybe let's say this is the handle, like this location is like a point patch in the mug. It's changing color from red to yellow, and then the next time it's changing from yellow to green to blue. Um, so this in this case, this arrow or vector is not like movement in the physical sense, but movement in the color space. And to me, in my mind, I think this movement can be sent to the sensor. Hey, there's like some movement in the color space, so that the sensor can still predict. Yeah, like I'm going to predict a yellow color now instead of red. So this is still quote unquote movement for me, just not in the traditional like movement in the physical
I think you'd be
space
really
sense.
careful using the word movement here, OJ,
Okay.
because movement implies you can do like path integration and changes the
Yes.
location. Not happening here. There's no
Mm,
possibility of doing path integration. I can't say that red always turns to yellow. There's no movement vector that says that. It's really just
right.
like these are just random points. Red became yellow. It could have become green. It could have become turquoise. I don't know.
Yeah.
There's no movement here. I think there's a change in time, and I think that would be the better language to use. That ID
Okay.
changes in time.
Okay. Yeah. And so I guess somewhat relate. Like I agree with you that they're like these changes are kind of just tied to the location and the orientation, perhaps, but not actual feature. Like this is not saying like, oh, like and look, this is tied to like the redness of the cup. It's just like whatever it is, it's changing by a certain amount and over a certain amount of time. And the reason why I'm saying this is because I think this is relevant. Like we don't want to learn like a change for every uh feature. Like I don't want it to tie to a feature so that we can generalize to like a different object later. So if we learn something that goes from red to yellow, like that behavior of changing color should be applicable even if the starting color was, I don't know, pink or something.
But my point is, how could it? How could I apply that one object changes from red to yellow to an object that's now green? How would I know what it's supposed to turn to? I mean, there's no way of generalizing, right?
Mhm.
It's not a behavior that can be applied um, that leads itself to that kind of generalization. I could say that another object's red might turn yellow.
Yeah.
But I
Maybe
can't
if you
apply it
think
to.
of like a traffic light, you you can apply that kind of red, orange, green behavior to
Right,
lots.
right. I just
Yeah.
said that, right? I said you could do that, but you can't say, oh, now I see a traffic light has a blue light. I can't predict what the other lights are going to be. It's like I've never seen a traffic light with blue light, and I can't. There's no path integration to color unless you were very familiar with the color wheels and color composition.
Yeah.
And you
Yeah.
can say, oh, I just moved 30 degrees on the color wheel. So I was like, I'm
Yeah.
gonna apply 30 degrees to the new color.
Yeah. I
It's
guess
pretty
this
rare.
like by drawing this axis, I was implying like, okay, look, I'm thinking about the hue, like in the color wheel stretch out, or whatever. It's not a big detail for my like this section. But yeah, so I
Yeah.
will just move on for now. Anyway, so in the behavioral model, like I know that we're not always drawing in 2D because we understand that, but basically there can be change in any of the features, so in any n-dimensional features, and we just happen to be drawing in 2 dimension because that's easiest. But it doesn't basically the I just wanted to kind of separate that, like this is not necessarily physical movement, but like movement in any space of that feature. So this is how I'm thinking about behavioral models, is that it seems that for me, like learning the behavioral models seems like we want to learn something like vector fields, except that we don't want to learn every single point. Vector fields are usually, like dense, but I don't want to learn like every single like arrow in every single like, location of that object. Um, the So like if I fill the, like the above arrow example of the stapler opening, like what's implied there is that, at this location, stapler is moving, a little bit up. Same for that location, same for that location, same for that location, and then there's no movement in these. Um, and so I think the way that we can learn behavior without having to like learn every single point is that we just interpolate, and maybe that's a cheap answer. But I don't really see how to do it otherwise.
And
So
we wouldn't store anything if there's no change. So like at all
yeah,
locations where you have dots, you just wouldn't store anything.
yeah. But yeah, so I was thinking about interpolation across time and interpolation across space. So if we want to, let's say, because let's say stapler is opening pretty fast, so we only observe behavior at time equals 1, and we missed the 2, and then we somehow caught time equals 3. Um, I feel like, I mean, maybe this is just a example that where it's like obvious, but yeah, maybe I'm cheating myself. But I think we can, if we learn a behavior, these arrows at time equals 1 and these arrows at time equals 3, then but if we need to guess the morphology at time equals 2, then I think we can interpolate between those two and get like an approximate morphology model. Like basically it's like, oh, like I don't know exactly what the morphology will be at time equals 2 because it never stopped there. But if I had to make a prediction, it's like, okay, like I will interpolate and then apply those movements to make a prediction about the morphology. And then so that's interpolation across time, interpolation across space. This is I was thinking about the example that Jeff gave last week, which was like squeezing a ball into like a egg or oval, something like that. Um, and I think this is analogous to the balloon, where like this is a case where all the vectors in the vector fields are different and thus difficult to learn because we either need to break it off into like millions of children, that like Scott said. But again, I think we can cheat and interpolate. So if we know that, so like if we know that we're squeezing on the top, by this much at one time point, like, so we're kind of squeezing in like both ways, but less on the left right and more on the top down. Then like I can reasonably, I think, in that time point, I'm not observing any of the other locations on the circle, like this point or that point, but I can assume that, okay, this by interpolation, um, there might be some behavior here if I need to, like, I don't think we need to like store these. I think we just need to kind of calculate on the spot if we need to predict the morphology of a different patch of location, a different patch um, for whatever reason. Yeah. So like when I think about, and I think also Niels mentioned kind of like something like approximate. Like I don't think we have like a strict exact movement for every patch in our like models, but we need to kind of on the spot kind of make some predictions, and I think we do it kind of approximately.
I
That's
feel
all.
like whatever mechanism that we use for interpolating of in a morphology model, we'd probably be using that for the uh, behavior model. Yes, like
Is it? Yeah,
okay.
yeah. So I'm not sure if this gets around like the learning of every single point of the behavior model, but I thought that this is just one idea that I had. But I think again the difficulty this depending on how we learn the behavioral model, I think that will significantly affect how we get to generalize it to other objects. Because again, like this is kind of we're learning a behavior on a location by location basis. So we learned this, let's say, on a stapler. How do we apply to a book? Like we need to somehow transfer the locations of the stapler. Like we have to map that into a book, and I'm not exactly sure how to do that. Even if it's not tied to a feature, it's still tied to like a location and orientation. So anyways, so I don't have an answer to that, obviously, and hopefully, and maybe we'll revisit it when we get through brainstorming. Um, all right. Oh, yeah. I didn't take 30 minutes. Yay.
Cool, yeah, those were really nice graphics too. I just
Oh,
added
Yeah.
the open question also like interpolation in time and how to avoid storing too many morphology models slash keyframes.
yeah.
And yeah, I think interpolation is a likely solution. But yeah, we can talk more about that too in the brainstorming week. Yeah, great. Thanks to all three of you for putting together those presentations. It was really nice and a good recap, and also nice to kind of hear these ideas in different words and different framings. So
Yeah.
a little list of open questions that came up today. Maybe I'll put them into a document and then share them, and you can add any other things that come to mind, and then we can hopefully answer them all in 2 weeks.
Yes.
Yeah. I made my own list too. So, um,
And then, yeah, Jeff, you mentioned you had some more ideas around the distorting objects, but maybe we talk about that.
I'll do that next time. I'm going to work on that. I think there's a bunch of things we talked about today are interrelated, and that makes it difficult, to conceptualize everything. So I was thinking about the role of the balloon in terms of scale, changes in scale, and but there's a general theme I'm working on here, which is, and this relates to interpolation. With there's a range of how many data points you have to store to make correct predictions about something. And we saw that with the logo on the cup, right? If the logo is just the logo, you don't have to store that many points. But if the logo is bending, a logo is changing scale, the logo's the more it deforms and changes in other ways, there's no other way. You have to store more points. It's logic. So that relates to which Hojae was just talking about in the behavioral model, that over time and space. I think that's all related. Anyway, I came up with a list here, basically the role of hierarchy and the attention issue, like how do we form representations at the top or independent modalities. I think the example of the logo with the parts moved separately is worth thinking through. The idea of changing ID versus changing orientation, scale, and location, we have to make that very clear. And then the issues of things like the balloon and a circle becoming an oval, we'll have to really have a clear theory about that. So I know those things I'm going to work on. So that was good. Today's was good getting us back in the mood here for this.
Right.
And then,
I may not see
we'll
you.
forget about it during the robot hackathon.
Well, right. Well, and I'm going to be on vacation next week. So
Okay.
Lots of
offline.
time to think about this stuff.
Right. So I'm going to come back on like Sunday. And I think our research meeting starts on Tuesday. So I'll be coming back with having not really. Maybe I'll be thinking about this over my vacation. Sometimes I do. So
Yeah.
middle of the night. Well, in the middle of the night, you wake up. You're just like, oh,
That's
what
when I
happened?
usually have the best ideas, when I'm
Right. When there's no
on
pressure.
vacation on the weekend or something.
So
Like this
anyway, I hope you all have a good time with Hackathon. I hope it works out great.